Hello everyone, I am Minakshi working as an assistant professor IT department KIET group of institution Ghaziabad. In this lecture I will be discussing about 8086 maximum operation mode. So let's get started. 8086 microprocessor can work in two modes. One is minimum mode, second is maximum mode. Mode selection pin MX bar defines the working of 8086 microprocessor in two modes. This pin will define whether the microprocessor will work in minimum mode and maximum mode. This mode selection pin is connected to VCC or at logic high, then the 8086 processor will work in minimum mode. If this pin is connected to ground, or we can say at logic low, then 8086 microprocessor will work in maximum mode. Both modes enable different control structure for 8086 microprocessor. When minimum mode is selected, then 8086 will provide all the control signals to implement memory and input-output operations. When maximum mode is selected, the 8086 microprocessor will work in coprocessor environment. It will define the multiprocessor configuration. So in this lecture, we will discuss about maximum operating mode. Maximum mode is selected by applying logic low or logic 0 to MX bar input pin. This defines multi-microprocessor configuration. Maximum mode is used only when the system contains external coprocessors. It can be 8087 arithmetic coprocessor, etc. Maximum mode operation differs from the minimum mode because in minimum mode 8086 generate control signals for basic memory and input-output operations. That is single processor configuration. Whereas in maximum operating, control signals must be generated externally. For maximum mode of operation, 8086 processor will generate control signal externally. And to generate these control signal, it requires a bus controller, 8288 bus controller component. Because when multiple processor will exist in a system, then they will compete for buses, or we can say global resources, the resources which are shared by the multiple processor. So a bus controller component should be there to generate control signals externally. Because for a maximum mode of operation, 8086 does not have NF pins. So these signals will be provided by the bus controller. Here, this is the pin diagram of 8086. It is suggested to students to go through the pin diagram lecture of 8086 before going through this lecture. So 8086 microprocessor can work in minimum and maximum modes. So some of the pins or control signals are common to both operating modes, minimum mode and maximum mode. And these common signals are listed here. These are multiplex address and data buses AD0 to AD15, address buses A16 to A19, multiplexed with status pins S3 and S6, mode pin to select minimum and maximum mode, read to define the read operation, test on wait pin, ready to synchronize the slow devices, reset pin to reset the activity of microprocessor. It will suspend all the activities immediately. Non-maskable interrupt and INTR for general interrupt, clock, VCC and ground. These are clock input and power supply input. So these signals are common to minimum as well as maximum mode. Maximum mode signals. So 8086 microprocessor works in maximum mode, and these following control signals will be generated. The maximum mode will be selected by connecting mode selection pin to ground, or we can say logic low. In maximum mode signals, first we have request and grant pin. Request grant 0 and request grant 1. These two pins. Request grant 0 has the highest priority over request grant 1. These pins are used to request and grant the bus's control. And these are the bidirectional pin, and the bus request will be granted or not. This will be acknowledged by this pin. So this is the bidirectional pin. Lock bar, bus priority lock control. Now this pin will define the bus priority has been locked. No more processor can request for the buses. Next, status S0 to S2. This will define the status of bus cycle, whether it is the memory operation, memory read operation, memory write operation, whether it is instruction of code fetching, or it may be input output related operation, interrupt technology. So bus cycle status will be defined by S0 to S2. Next, QS0, QS1, instruction queue status. Bus interface unit has a queue where the instruction bytes are prefetched and stored in this queue. So these two pins will show the status of that queue. So here, as we discussed, S0, S1, S2 bar control signal will define the operations, status of operation, or we can say bus cycle. And these three signals will be observed and decoded by the 8288 bus controller. And various operations are denoted by these three status signals. These are interrupt acknowledge, input read, input output write, hold, a code fetch, memory read, memory write, or a passive state. No bus cycle is being used. Next, request and grant bar pin. Request, grant, 0 pin and 1 pin. Bus request grant pin request direct memory access during maximum mode operation. These lines are bidirectional and are used to both request and grant PMA receivers. Lock output is used to lock peripherals of the system. This pin is activated by using lock prefix on any instruction. Queue status pins. Queue status bits show the status of internal instruction queue in bus interface unit. These pins are provided for access by numeric coprocessor 8087, for example. And the status of queue can be queue is idle, or first byte of the code is being fetched from the queue, or queue is empty, or subsequent byte of a code is being fetched from the queue. Maximum mode model. So here in maximum mode, we have 8086 component, and in this a mode selection pin will be connected to the ground to select the maximum mode for 8086. And we have some common signals generated for maximum core, and as well as maximum mode will have some control signals. So here we have component 8086, clock generator component, which will provide the clock input to the 8086 microprocessor. And in maximum mode, some control signal cannot be generated by 8086 because it is a multi microprocessor environment configuration, and to generate the signal, a bus controller will be used, and this bus controller will observe three status signal and will provide some advanced signals for memory read, memory write, input read and output write. The maximum mode will have extra component bus controller. In the basic architecture, we will have the memory, both type of memory, RAM and ROM, input output chip. So we will have components related to memory and input output. And these components will be accessed by address or data buses. And we have seen that the 8086 microprocessor has multiplexed address and data buses. So demultiplexing circuit must be there. And we connect a latch with the address pins of the address buses so that the address can be latched. And we connect data buffers with the data buses. And this data buffer component will receive a data direction pin, which will define the data direction, whether it is data transmitting or data receiving. And it will also have a data enable pin to show that the data on data buses is a valid data. As we have discussed in previous lectures, that the memory in 8086 microprocessor is organized in even and odd banks. So even and odd bank selection logic must be there. So this model also has a chip selection logic, which provides the signals for even and odd bank selection of RAM, even and odd bank selection of ROM, and its chip selection mechanism for input-output chip. And we have seen that the bank selection is driven by two control signals. One is BHE bar, second A0 address pin. So this chip selection is receiving two control signals A0 and BHE bar. In maximum mode model, the extra component bus controller is added to generate control signal external. Those signals which cannot be provided by the 8086 microprocessor. So in maximum mode model, whenever coprocessor environment exists, then the bus controller component is added, which takes some signals from 8086 microprocessor and produces some control signal for multi microprocessor environment. So in maximum mode model, we will have a component 8086, clock generator, then a bus controller, memory component, RAM, ROM, input output chip, chip selection logic for bank selection or chip selection, and demultiplexing component of multiplexed buses, address latch or data buffers. In this way, we can draw the maximum mode model for 8086 microprocessor. These are the references for this lecture, a maximum mode of 8086 microprocessor. Thank you very much. Happy learning.